The question is, what is the force between two small charged sphere having charges 2 into 10 to the power minus 7 coulomb and 3 into 10 to the power minus 7 coulomb placed 30 centimeter apart in air? Let us solve this question step by step. Given charge 1, that is Q1, is equal to 2 into 10 to the power minus 7 coulomb and Q2 is equal to 3 into 10 to the power minus 7 coulomb. Also, the distance between these two charges, that is R, is given 30 centimeter, that you can write in meter as 0.3 meter. Now, from Coulomb's law, force between two charges is given by K multiplied by Q1, Q2 and divided by the distance square, where K is equal to 1 upon 4 pi epsilon naught, and epsilon naught is the permittivity of free space. The value of K is 9 into 10 to the power 9 Newton meter square per Coulomb square for both air and vacuum. Hence, substituting all these values in the formula of force, we get F is equal to K is 9 into 10 to the power 9 Newton meter square per Coulomb square multiplied by charge 1, that is 2 into 10 to the power minus 7, and another charge is 3 into 10 to the power minus 7 coulomb, and that is divided by 0.3 square, that is the distance square. And when we do the calculations, we get F is equal to 6 into 10 to the power minus 3, and since the unit of force is Newton, so we will put N. And since both the charges are positive charges, so there will be a repulsive force, so you have to write repulsive force. So repulsive force of 6 into 10 to the power minus 3 Newton is our answer.